So a little bit about that. Let's dig into the spectrum and the tiering structure itself. So there's 3 tiers to CBRS as a spectrum band. Tier 1 is the incumbents. Those incumbents include U.S. Navy radar. So it's mainly shipborne radar when they come near the coastline on large aircraft carriers. And there's actually only 17, I've got it on an upcoming slide, there's like 17 aircraft carriers that could come in very specific coastal areas along the U.S. And so that's one of the incumbents. There's also, I think, 3 ground-based radar installations that could also be an incumbent. There's also fixed satellite service. So there's some satellite service organizations out there that have receive-only capabilities on this band at very specific locations throughout the continental U.S. Very, very specific. So the U.S. Navy is kind of like a mobile, what they call a dynamic protection area, because those aircraft carriers can move and dynamically come into different areas along the coastline. The fixed satellite service is fixed. You'll know specifically if you're impacted in one of those areas, and you can easily avoid what frequency slice they're using in that area. The third one in the incumbents is the wireless service providers. We're not going to spend a whole lot of time on them. They're being sunset, so most of the wireless service providers that have use of the spectrum are being moved into the SAS kind of process and procedures as well. For most WISPs, that is happening this year in 2020. There's a few that are going to be grandfathered in until about 2023, but very, very limited use. So they're going to fall right into everybody else with the Tier 3 GAA that we're going to get to. Tier 2 is a priority access license. So a big focus for the FCC with CBRS actually was enabling 5G deployment across the US. This is a prime 5G target band. So what they wanted to do is they wanted to make it accessible for organizations, whether they be big or small, to try to get priority access to some of the spectrum for 5G use cases. And so what we see is they're going to have access to the lower 100 megahertz only. And we're going to get into some technical details because they can't use all of that 100 megahertz. So it's going to be auctioned on a county-by-county basis, and we'll get into the details with that. In any given county, only 70 megahertz can be auctioned off. So of the 150, you're guaranteed for GAA to have at least probably about 80 megahertz for use. And then Tier 3 is the general authorized access, which is essentially if the device is certified by the FCC and you register with the SAS, you can use the spectrum. Again, it's a 10 megahertz channel structure. And one other note about the priority access license, I mentioned in every county there's only 70 megahertz that could be auctioned. Any one bidder can only win 40 megahertz. So nobody can kind of consume all of the spectrum and just take it. And the reason, and there's a big backstory as to how the auction would happen. There's a lot of political maneuvering on the back end. Originally, it was based on census tracts. Then because of the whole 5G and operator influence, they went to a little bit larger area on a county-by-county basis. That way, operators that might be bidding, let's say, for large metropolitan areas like the New York City metro area, don't have to do it on a census tract because it wouldn't make sense for them to potentially try to deploy 5G on that small a basis. So there's some compromise there. But again, where we're looking at for most enterprise deployments is probably the GAA Tier 3. In rural areas, it might be cost effective for enterprises to start bidding on priority access licenses, but it's going to be dependent on what your use cases are and how much investment you want to make.
So I was going to ask, you want to be getting into this, but who are the players to buy that?
Yeah, so the question is, who are the players to buy the priority access licenses? In the big metropolitan areas, it's going to be the large MNOs. It's going to be the Verizons and AT&Ts and T-Mobile Sprints of the world, right? Because they're going to see this as a prime 5G band to deploy, in those large markets. The price, per bit per megahertz is going to be really high in the metropolitan areas. The price is going to be much lower in the rural areas, which might make it, affordable for enterprises or managed service providers or WISPs to try to buy some of that spectrum. Question?
So RF doesn't exactly adhere to county lines. How are they kind of managing that overlap?
So the question is, RF doesn't adhere to county lines, right? So if you buy a priority access license, you have exclusive use of that license in the county. Neighboring counties, they're going to have potentially be able to use this auction off the same spectrum. Through the spectrum auction process, again, it's 100 megahertz, but only 70 megahertz out of that. So my anticipation is that they'll try to stagger them a little bit in between counties so that, maybe this 70 megahertz doesn't completely overlap with the next county, so that there's channels that you can use like maybe on the edges or something like that. That's a good question, though. The other one is that the priority access license holders still have to go and integrate with the SAS. So they don't know specifically which 70 megahertz they're going to get access to. They're just going to get access to a chunk of spectrum that they've bid on. So they can try to buy up to 40 megahertz. They don't know which specific 40 megahertz. The SAS will still handle that dynamically.
Okay, so that is dynamic.
It will be dynamic, yep. So the anticipation there is then that radios that are deployed along, let's say, a county edge and other radios along the neighboring county edge, the SAS will handle that, determine the optimal frequency assignments for those radios, because they have sophisticated modeling on the back end. They use a couple different modeling kind of algorithms that they'll go through, and when those devices register, they'll go through the modeling process and determine what the best frequency assignments would be. I think this is getting stuck. I'm going to just use the keyboard. Okay. So how much is 150 megahertz? Because we have this question come up quite a bit is, well, it's not nearly as much spectrum as I have in Wi-Fi. What can I really do with it? A couple things to think about here. Compared to what licensed frequency is out there for big mobile network operators today, and 150 megahertz is actually quite a bit, especially since it's in what we call mid-band spectrum, which is good RF propagation characteristics and attenuation characteristics for high-speed mobile broadband. It's more mid-band spectrum than most, or actually all of the licensed carriers have today. And then the other thing that we'll get into is when we get into the LTE topics, we'll understand how frequency reuse happens in LTE that makes it, higher efficiency than potentially Wi-Fi, and you can get greater frequency reuse out of LTE. So you can actually reuse those channels more often without having negative interference kind of aspects. Yeah, question? No, I'm good. No, I'll be all right. Thank you. So let's talk about the different tiers in a little bit more depth. So tier 1 is the incumbents. It's mainly shipborne and ground-based radar in very specific locations. So these are covered by what the SAS calls dynamic protection areas. Since the aircraft carriers are mobile, obviously, we don't know exactly where they're going to come in along the coastline. Yep. And so they're dynamic protection areas then because we have to dynamically sense through the ESC networks that the SAS is deploying when they come in range, which frequency slice they're using, and then get the CBSDs or the radios to switch channels to avoid interference. The protection is guaranteed or needs to be activated per the FCC within 60 seconds. So if an aircraft carrier comes in within, it's like 40 kilometers of the coastline, the ESC network will detect it and has to register that in its system within 60 seconds and start notifying the affected radios that are deployed out there to change channels. Really, there's only 17 ships at 3 main sites. Those sites are Norfolk, Virginia, San Diego, California, and Seattle, Washington. That's where the prime kind of areas are that might be impacted. But again, the red areas there show you that anywhere along the coast are required to be covered by that ESC network. And typically, the other thing to note is they're not taking up or not impacting a large amount of spectrum. The aircraft carriers are really only using about a 5 megahertz slice of spectrum. So when they do come in range, the ESC will detect which 5 megahertz section is being impacted, and then move the very specific radios in that DPA area that are overlapping with that 5 megahertz. So it's not like when they come in, you're going to get kicked off the entire CBRS spectrum or a large portion of it. It's really very specific radios that happen to be operating on the same channel that impacts that 5 megahertz. Yeah, question?
Can a tier 2 or a tier 3? Or can a tier 2 bump a tier 3 if they're getting relocated and be allocated to other spectrum?
Yes. So the question is, does that impact tier 2 and tier 3? And the answer is the incumbents, yes, impact both tiers below. And if a priority access license holder gets kicked off a specific channel and that radio moves to a different channel, it would be within the PAL area, the lower 100 again. That's kind of why we can only assign 70 out of the 100. We got to, if they get hit by the radar, they need to move to some open spectrum. So they have, those other 30 megahertz within the PAL tier to move to potentially. And then if there's GAA that gets impacted, they would have to move as well. But that's what the SAS is there for through their protocols, to optimize that with the minimal impact.
So the SAS will actually tell them where to move to, as it was channels.
That'll be covered in the CPI training that you're going to have access to, a little bit more in depth. The SAS will not necessarily tell the radio which other frequency to move to. The radio gets notified, and then it does a SAS inquiry. And the SAS inquiry is essentially the radio asking the SAS, okay, given my location, which spectrum is available? That 5 megahertz chunk will be taken out of that because it's been detected. And it'll tell you, you have options of these 4 channels, which one do you want? And then the radio can try to register for one of those open channels.
How often will it go back and try to reuse that channel?
That's a question I don't know. So the question was, how often will it try to reuse that channel that got impacted by incumbent? I don't know what the timer is for not sensing the incumbent anymore and then reactivating the channel. I'd have to look that up.
And what's the behavior if the SAS is unavailable?
If the SAS is unavailable, the spectrum grant that it gives to the radios is kind of in perpetuity. So there is a heartbeat that every radio goes through to sync up with the SAS. And I'd have to look up that timer as well of exactly how many heartbeats can be missed. It's not super stringent. Right now, it's I think 24 hours on the SAS backend that you can operate on that grant without renewing it or by losing the heartbeat. So, but that's some of those standards that are still in flux. They've changed a few times, so I'd want to go back and verify exactly what that timer is now.
Andrew,
Yeah.
how is the location determined by the radio when it reports to the SAS?
The radio itself, a GAA deployment or the ESC sensor?
Either.
So the ESC sensor is, they've deployed it, they know exactly where it's at.
That's by the
Yeah.
5 companies, right?
Yep. So yeah, for more generic deployments, that's part of the CPI certification process. Every radio needs to be tied to a geolocation. So indoor CPI is not required, but you still have to put in its location. Outdoor high-powered, it has to be, that's why you're certifying it as a certified professional installer, that it is in this very specific location. And there's a process that every manufacturer like Celona is developing for the system to be able to dynamically either look up GPS location, because a lot of LTE base stations have a GPS receiver component on them. They can sense GPS and register it automatically in the system. Or if you happen to be indoor and need to register the GPS, you could do that manually in the system as well.
Did you say indoor low power doesn't require CPI to do it?
Correct, yep, and we'll discuss that in a little bit, but there are 2 classes of radios. There's category A and category B. The indoor, well, it's roughly indoor-outdoor, but don't use that as a guideline because the indoor ones can be deployed outdoors. They just have some restrictions. It's mainly low power, high power. And the low power ones, which are meant for indoor deployments, do not have to be installed by a CPI. Just the high power ones, because there's greater risk with that.
Hey, Andrew, when you say
Yeah.
indoor high power, is it just like you say, or do you have to select each EDM, or how does that work if you're indoor outdoor?
Yeah, category A, category B is really based on power output capabilities of the device. So you're going to know when you buy a device if it's category A or B, because it's certified category A or category B at time of manufacture. So every device is certified for one or the other. And we'll get into what the power limits are in that. And think of configuration just like you would with Wi-Fi. It's a max. You can configure whatever you want below that. Question?
So indoor then, does that mean anybody can install indoor CBRS, just like anybody can install Wi-Fi?
As long as the device, so the question is, since indoor or low power doesn't require CPI, can anybody install it? The answer is yes, as long as the device and the solution that you buy has been certified and interoperates with the SAS. And you need to make sure that it can connect to the SAS. So if you have, one of the things we'll get into is, since it's an enterprise network deployment, it's riding on an enterprise network that you're in control of. So if you have firewalls and things like that that block its integration with the SAS, you would be out of compliance. So you still have to operate it in a compliant fashion, but you don't need to have a certified installer do it. Does that make sense? So this is an example of, one of those dynamic protection areas that could get activated if an aircraft carrier comes into the coastal area. So the ESC sensor network covers the coastal areas, and if an ESC sensor detects the aircraft carrier come in, it would activate one of these dynamic protection areas, or that activated protection zone in blue there. Now, the exclusion zone are just all the areas along the coast that are covered, so don't worry about that too much, but just know that it'll activate a zone potentially between 40 to 80 kilometers from where it detected the incumbent activity. 40 kilometer for the low power category A devices, and it'll activate it for up to 80 kilometers for the outdoor high-powered devices. So again, outdoor high-powered have more potential to interfere with the incumbent. It has a little bit larger area that it needs to take into account when moving those units to a different channel. So that concept makes sense? Any questions on ESC and dynamic protection areas? Okay. The other incumbents are fixed satellite services. So there's really only 35 or so fixed receive-only sites in the US. These sites are not protected by environmental sensing capabilities from the SAS. They're very stationary, they know where they are. So the SAS has those included in their modeling. And so they don't really need to dynamically detect when they're operating. They're just assumed to be operating in those areas all the time. And again, these fixed satellite providers have very specific, well-defined frequencies that they operate on. So again, it's very, very well-defined. When you go in for a grant, you're going to be able to get spectrum in those areas still. There's just going to be very small sections of the spectrum band that are excluded in those specific areas. The SAS does, through their modeling, compute aggregate interference. They compute in the modeling 150 kilometers radius out from these locations for co-channel interference, and 40 kilometers for what they call blocking interference above a certain power level. So again, SAS is just doing a lot of back-end sophisticated modeling. When you register your device, it needs to take into account how it's going to impact that fixed satellite between 40 to 150 kilometers, depending on what your output power is. Question?
Are those sites spread across the band, or are they generally more in the provider or the general access?
Yes, the question is, are those fixed satellite providers spread across the entire band or limited to a certain range? If we go back a couple slides, you'll see that the fixed satellite service is really mainly the only in the upper 100. So we kind of got this thing of all 150 is could potentially get hit by the Navy incumbents. The fixed satellites in the upper 100, the WISPs we're going to ignore, and I suggest you ignore for now as well. And the PALs are just in the lower 100. So you can see there's multiple variables stacking up that kind of make it a little bit. This is why we have a SAS that's very well defined to be FCC approved for operation. They've got to kind of take different aspects into account for different portions of the spectrum. Okay, so this is my 2-second spiel on the WISPs aspect of the incumbents. FCC Part 90, which is what they're defined under, is sunsetting those. It's sunsetting most of those providers and moving them into Tier 3 GAA in CBRS by the end of this year. So I wouldn't spend a whole lot of time, if I were you, worrying about the WISP aspect. They're going to be sunset and gone, and they're just going to fold in with everybody else. They are, for right now, like for the next year, they're computing aggregate interference again to 40 kilometers out from those sites, but that's being sunset. So The question is there a way to look up what those WISPs are? I'm not aware of a way to look them up. I'm sure they're registered somewhere with the FCC. I'd have to do some more research to figure out exactly which ones are where. All right, let's talk about Tier 2. So Tier 1 was incumbents. We've seen how they're protected. Let's talk about the priority access licenses. So the auction, again, I mentioned earlier, it's based on a county level basis. I just want to give you a flavor for why it's county level. The operators, like the Verizons and AT&Ts, lobbied very heavily to try to get these areas as large as possible. They started out very small on a census tract basis, but the carriers wanted them to be what they call a CMA or a cellular market area. So the FCC for licensed spectrum defines these cellular market areas that are very large areas that conform to how carriers need to buy spectrum, not only so that the government can get the most out of the auctions, but so that the carriers, and then when they invest in equipment to deploying their cellular networks, can cover an entire metropolitan area and beyond with the same set of spectrum. They don't have to get too complicated. So a cellular market area is actually a very large area that encompasses many counties. So what I'm showing you on here is that compromise was census tract versus CMA. They landed in the middle on county level basis. So this is the New York City area, and you can see the cellular market area covers the entire area on the left, but there's 17 counties in that area. So for CBRS, it's broken down into kind of a hybrid. It's smaller areas than typical cellular licensed spectrum, but it is big enough that they can try to get operators to deploy it on somewhat large-scale basis. The other aspect about the auction is that the winners for the county level auctions do have to conform to performance requirements. So there's some requirements. It's a 10-year term for the license. By the end of that 10 years, they have to have met some performance requirements like serving a certain amount of the population in order to keep that spectrum.
Is it just tier 2 that auctions, right?
So the question is it just tier 2 for the auctions? The answer is yes. Yep. So here's how the priority access license holders would actually acquire spectrum. They don't get very specific channels or frequencies. They get a certain amount of spectrum in the lower 100 megahertz, and they integrate with the SAS, just like everybody else in GAA Tier 3, and the SAS will grant them that amount of spectrum that they've auctioned off and licensed to that specific provider. So what you could have here is you could have contiguous or non-contiguous assignment of the PAL licenses to any given operator. So here you can see bidder A might have won 40 megahertz. The SAS will dynamically give them 40 megahertz in that band, potentially split up between two different areas of the lowest 10 megahertz and maybe the upper 30, for instance. And then bidder B might win the other 30 megahertz out of the total 70 that can be auctioned off in a county. And then they might get some contiguous spectrum in there. This is not defined how it's going to happen. This is just an example that they dynamically still acquire specific channels just like everybody else. And so, yeah, the verbiage there is that the SAS will try to assign contiguous spectrum to the PAL license holders to the extent feasible. So if their algorithm determines that it's feasible in that specific location, they'll try to give them contiguous, but it's not guaranteed.
So that makes the bidder A and the bidder B, it can change. They just have 40 megahertz of that. They don't have specific frequency.
Yeah, so the question is the bidder A, bidder B, the 40 megahertz and the 30 megahertz could change. The answer is yes. So if an incumbent comes in, they dynamically register, get a grant for very specific channels on radios. And it could be dynamic in that 100 megahertz. An incumbent could come in and they can still force them to move. So that's why they don't get very fixed channels. They still need to move if an incumbent comes in. Question?
Can there be 7 bidders or just?
So the question is how many bidders can win? I'm not entirely sure. I would imagine my assumption is that up to 7 bidders could win because they're in 10 megahertz chunks or channels. I'm not 100% sure though. My anticipation is that in larger areas, the operators are going to try to buy as much as they can. Based on an operator bidding level basis, they're probably going to win like the highest level bidder, if they wanted 40 megahertz, will take it, and then the next one will probably take 30, especially in the large metro areas. In the more rural areas, if enterprises bid or WISPs bid and they only want 10 megahertz, 20 megahertz, you could probably have more than 2 or 3 or 4 bidders win licensing. Kind of TBD on how that shakes out with the license or the auction process.
So the extra 30 megahertz, just dynamic, leaves room for the tier 1 guys, but it also leaves room for tier 3 operators.
So the question is, the extra 30 megahertz in the PAL block of 100 megahertz leaves room not only for the incumbents, but also for tier 3 GAA, and the answer is yes. So GAA users can use any of the spectrum that the PALs haven't taken. So the 10 megahertz chunks, those 3 that aren't taken in that band, can be used by GAA as well. And again, if an incumbent comes in, then they move. And if an incumbent comes in and let's say bidder A has to move off of one of their channels and they take one of those, then the GAA users, the radios that are in the interference area for the specific ones that moved could get impacted as well. So there's kind of a little bit of a cascading process there, yeah. But again, think of it as, an incumbent's coming in with 5 megahertz a chunk along the coastal area. So only one channel is likely to be impacted, and it's like geolocation zoned as well. So only the radios that would actually interfere then with where the PAL moved could cascade. So hopefully it should be narrow in scope.
But I can see in a large metropolitan area, New York City or Atlanta or something, where your GAA user could get bumped off, basically.
So the question is, like in large metro areas like New York City, you can see where a GAA user would get bumped off.
Especially if,
So, I don't want to overestimate it because the impact of the U.S. Navy incumbents is very, very minimal. It's very rarely that they come into one of these areas. Yeah. Yeah. So I mean, it's either well defined in one of those 3 areas like Norfolk, San Diego, or Seattle, or it's going to be very sporadic. Or infrequent, I should say, not sporadic. So again, it's tier 3 GAA then is, it's similar to unlicensed where it's licensed by rule. There's no auction process, you don't have to pay any money, but you do have to conform to the rules that the FCC has set out, and that means becoming certified with both FCC and WinForum. And the WinForum's that SAS integration components. So estimates on how much spectrum we actually anticipate being available for GAA and Tier 3. If a PAL is not deployed and active, you could use all 150. And so that's the requirement there is even after the auction date, which is going to happen next June here, if they haven't deployed radios on the specific channels that they've been granted PAL licenses for, you can still use it. So they actually have to deploy radios in that specific area on that specific channel before it would the SAS would not grant it to you. Once the PALs are auctioned and they've actually become live and they're deploying and they're out there, realistic use case is, we anticipate in most areas 110 megahertz still being available. Not all of the PALs will be deployed in a given county or in a given geolocation. A very conservative estimate is 80 megahertz of spectrum for GAA, assuming all the PALs have been auctioned and deployed in that location. And then the worst case is if you're in a DPA along the coastal areas or one of those fixed satellite service areas, you might have another 5 megahertz that on a channel that you can't use. So take 110 megahertz out of the equation and then you'll go down to 70 megahertz. So very, very worst case is you should have about 70 megahertz of spectrum to use. So when we get into deployment scenarios, some organizations say if it's available, let me use it. Other organizations are going to be more conservative and say, I want to plan for worst case. That way I never get impacted potentially. And so then that's kind of where the lay of the land is. If you're being very conservative, you might do 80 or 70 megahertz and just say that's still enough for my use case. I don't want any dynamic impact potential, even though it's very minimal risk. So I'm going to go ahead and just deploy on 70 megahertz. We're advising most customers through we're talking with their use cases and understanding where they fall on that risk scale and trying to, advise them properly.
How much would you typically use for like a small warehouse? If it's
So the question is, how much spectrum would you actually use for, let's say, a warehouse with scanners or something like that? Again, that gets into very specific application use cases. For a warehouse, I'm very familiar with warehouses. You could probably do it all on one channel if you wanted to, because LTE with the frequency reuse can allow that to happen, especially in low bandwidth environments. Higher bandwidth environments, you do want more channels to have the capacity and to spread out that frequency reuse, just like you do with Wi-Fi a little bit more. So it's really dependent on the application and that application's tolerance for bandwidth, latency, some of those performance targets. Was there another question over here? No? Okay. So let's get into the channel structure. Don't worry about the complex formulas there. I just wanted to put them up there so you know, have it as a reference when you get this material after the session today. You can find the frequency to channel mappings in a 3GPP spec, and that spec is in series 36, which is essentially the radio or the RAN access network specifications. So it's 36.101 is the tech spec for this. And the channel numbers are called EUTRA, absolute radio frequency channel numbers, ERFCN. It's a mouthful. Don't worry about it. This is similar to your Wi-Fi channels 1, 6, 11, or 5 gigahertz, 36, 40, 44. What they do is there's this formula that maps the frequency to an absolute channel number, and the channel numbers span every band that 3GP operates in. So every unique band, every channel is very uniquely numbered, and so this is a global numbering scheme for all of 3GPP. So band 48 is CBRS. It falls into the, a portion of this table where they, do the mapping from frequency to channel number. And that's the formula for you, where the variables there are, the low frequency is 3550 megahertz. And the offset, or the starting numbering for this band is 55240. So the way that plays out then is here's your frequency to channel number mapping. If you're like me and you will not remember this or memorize it, you're going to have to print it out and remember this, just like you would. You've probably memorized Wi-Fi channels just using them enough. Once you use this enough, maybe you'll memorize it. Until then, keep the table handy. Since there's no real concept of static channel planning in CBRS, though, you probably don't need to know it if you don't have to. Just know, like when you're looking at stuff in a radio, what that number means, where it references to, and if you want to look up the mapping, you can. So the numbering actually happens on a 1 megahertz basis, but I've kind of condensed it down into 10 megahertz because that's the smallest channel width available for CBRS. So if you had 10 megahertz wide channels, that would give you 15 channels in the CBRS band. I've highlighted them in blue. Again, just like Wi-Fi, the conformance here is you reference the center channel frequency. So the center channel frequency for channel 55290, the top one on the left there, is frequency of 3555 megahertz. So 5 megahertz below, 5 megahertz above. If we look to 20 megahertz channels, then you would potentially have 7 20 megahertz channels available. This is one example because you can skew those channels to the low end of the band or the high end of the band because you have about 10 megahertz of wiggle room there. So if you're skewing it toward the low end of the band, these would be your channel numbers for 20 megahertz. Any questions on channel numbering? Yeah.
Or channel reads. So is it like Wi-Fi that if you have, say, your warehouse, you have 3 CBRS access points, they're all going to be operating on a different channel?
So the question's about frequency reuse. So if, let's say in a warehouse, you said, if we have 3 radios and they're all operating on different channels, more than likely, yes. What we'll get into is cellular's SON capability, which is similar to RRM, or radio resource management. It's called self-organizing networks. It's the process by which a manufacturer's equipment will determine through the SAS integration what spectrum is available and then allocate that to a system of radios for the most optimal configuration. You can operate LTE on a single frequency, which is definitely doable. Licensed operators do this all the time. And that gets into more of later today when we get into LTE and how the protocol handles interference. The short answer is, unlike Wi-Fi, it doesn't do preamble detection and back off. So Wi-Fi is completely blocking. If I hear a preamble, I have to defer and wait. LTE does not operate that way. Number one, all the radios have a sync process, and they can actually sync their frames in the time domain so they don't overlap, and they can schedule them so they don't overlap. And the other thing that they can do then, hold on, the other thing that they can do is, instead of treating it as complete back off and deferral, they treat it as just interference, as raising the noise floor. So it influences the SINR noise floor for a given transmission, but I can still transmit at the exact same time on two different base stations on the same frequency. They're non-blocking. I just might have a lower MCS data rate because my noise floor is a little raised. That gets into some more, very technical design parameters of where your sectors are, where they're pointing, where their sectors are covering, and how much noise that introduces. But just know it's non-blocking. So, and that's what we'll get into as well when we start doing network planning, as we'll see if I start ratcheting down how much spectrum I'm using to serve a given capacity requirement. The number of radios to deploy does not scale linearly with how much bandwidth I have, because I can actually reuse that frequency more often than, let's say, I could in Wi-Fi. You still need to do some channel planning potentially, and the SON will try to take care of that dynamically in the system, but it's just, I would say, not as impactful as in Wi-Fi, if that makes sense. Question? The question is, can we expect a capacity planner from me? No, not me particularly. Celona has one that I'm going to highlight later on today in the planning section. We have a web-based tool that can give you a rough order of magnitude of how much spectrum you have available at a location and how many radios you need. We'll go into that.
So the frequency coordination and the time domain coordination of this section is a TMA variant.
Yeah. So the question is, the frequency coordination for interference in CBRS specifically, since CBRS uses TDD LTE, or time domain duplexing, it's TDMA, essentially that same concept, yep. But all the radios are syncing up through their EPS, or through the system, since LTE is more than over the air spec. LTE is the portion of the over-the-air spec. The other one is the EPS, or the Evolved Packet System, which is the packet core and all the control plane functionality and all that. It operates as a system, so as a system, it can sync those radios up to coordinate that in the time domain so that they don't interfere. Yeah, question?
So when you deploy CBRS, you check in with the SAS data, you know what spectrum is available. Is that the same for low power deployment as it is for higher power?
So the question is, when the radios at CBRS check in with the SAS for power levels, is that the same for low power and high power, category A and category B devices?
I assume if you're low power deployment, it doesn't really matter what's being used miles down the road, because
Yeah, so both category A and category B are required to integrate with the SAS, request spectrum, and the SAS does modeling. So when what you're going to go into the CPI training when you get the voucher for that and go through that training, they're going to tell you what those specific requirements are and how the modeling happens. The modeling, so when the radios register with the SAS, they actually register not only their GPS location, they register their install height, their antenna gain, and azimuth, which is orientation, so that the SAS has all the data it needs to accurately model the RF propagation and impact. And the ranges that it models for indoor are less than the range for outdoor. So yes, it still does all the modeling for the indoor, and so it'll actually model indoor radio interference with, let's say, your neighbor as well, to understand what the best frequencies are to potentially allocate. And then from there, any given enterprise's SON aspect of their own infrastructure would then optimally delegate those radios out to the different radios, or those channels out to the different radios. So the interesting thing we'll get into is there's a concept of a domain proxy, where not every radio has to check in with the SAS. It can be offloaded to a centralized element. In Celona, we implement our domain proxy in our Celona Edge, which is our packet core. So let's say you have 100 radios across this, this building. The domain proxy in the core is going to integrate with the SAS, know the specific location of every one of its radios it's managing, and each radio could have a different subset of that spectrum that the SAS is saying is available for it. So the ones on this edge of the building are next to a neighbor. That neighbor's already operating on these specific channels. So to avoid that, maybe you have a different subset available on these 4 radios than the 10 radios over on the other end of the building. So every radio will have a different subset of frequencies that the SAS will grant it, and that's the job of the domain proxy, is to optimally figure out what the best arrangement of those channels are for frequency reuse, non-overlap, and performance.
That's a customer-owned device, the domain proxy.
The question is the domain proxy a customer-owned device, and it's yes. This isn't, we're talking about enterprise-owned and controlled deployments. So for CBRS, by and large, it's either going to be the enterprise owning the radios and its own packet core and all the related systems, or it's going to be like a partner and a managed service provider that will own it and help the customer through that process, but completely controlled by the the enterprise or the community.
Do the radios use Ethernet as transit to the core, or is it some other proprietary transit?
Yeah, so the question are, do the CBRS radios use Ethernet as a transportation to the core or backhaul? The answer is yes. Most CBSDs or CBRS service devices, which are the radios, use either Ethernet, Cat6, or they use fiber. They're kind of like a cellular small cell, essentially, is what the terminology is from a cellular perspective. I have yet to see one that doesn't support one of those 2 methods. I mean,
Anything makes it into an IP network, or do they have to be completely segregated networks?
so the question is, does it work on an IP network, or do they have to be segregated? It's dependent on the manufacturer's implementation. So if, let's say there's an MNO, like Verizon or AT&T is coming in to try to sell you private LTE, they might want it completely dedicated, and they want to run their own fiber, they want to control everything and just sell you private LTE. The Celona approach that, I don't want to, this is a vendor specific thing, is we integrate with an enterprise's existing network. So our radios are just like Wi-Fi APs. They plug into your switches, they use your cabling, you plug in the packet core, which is the Celona Edge, into your network. You have routing, you have firewalls, you have everything in between. This is really an overlay to your existing enterprise network.
How does the certified engineer do their planning to provide that information?
So the question is, how does the certified engineer do their planning to provide that information to the SAS? Yeah, so really it comes down to the technician doing the install doesn't have to be the CPI certified individual. The CPI certified individual is just the one taking accountability for the system. And that's really mainly for outdoor or high power installs. So there's a process that, again, going to be manufacturer dependent to make sure that you have correct GPS coordinates for every radio installed. Outdoor, more than likely, that's going to look like GPS units that are bundled into the small cells. Almost every small cell is going to be manufactured with GPS built in. It might look like a separate little antenna off the system. It might be an integrated antenna. Indoors, where GPS is harder to acquire the signal for, then it's going to be a manual or automated process within the manufacturer's specific system to assign GPS coordinates. So that could be a technician that has an app on their phone that can acquire the GPS signals and dynamically map it to a radio, or it could be manually putting it in the system somehow, or somewhere in between. It's pretty much implementation dependent.
In terms of design, though, how do you do a design to provide specs of height, estimates, and all that?
Oh, yeah. So the question is, how do you do the design for the CBRS radios? I'm going to get to that in a CBRS planning section just a little bit later today. We'll go through essentially predictive modeling as well. Well, we'll go through the Celona network planner for how many radios you need given capacity and location. We'll go into very specific predictive modeling, just like you're familiar with Wi-Fi. You'll do an install. You can also do a site survey afterward of live measurements. Very similar process to how you do it with Wi-Fi, just a little bit different technology underneath. Is there any other question? Yeah. Can you speak up a little bit? I can't hear you. Oh, if there's a quality service mechanism in this technology, yes. It's very complex. We're going to get into it later today in the LTE section. So I don't want to dive into it now because it can be a kind of lengthy topic. We're going to get to it though, yeah.
So it's technology dependent, so if it's LTE, it would be kind of LTE quality of service, it's something different.
So the question is it technology dependent? Like LTE, it'd be LTE's QoS. If it's 5G, it'll be 5G's QoS. Yes. So CBRS is just the spectrum. How you use it, what protocol you run over it is going to be LTE today, 5G in the near future. And LTE has very well-defined QoS with EPS bearers and things like that we'll get into. 5G has analogous QoS mechanisms.
Yeah, regarding the Ethernet connection to the backbone, what speeds would normally be 1 gig, 1.5, 5?
Yeah, so remember right now with CBRS, the question is what speed will we need on the backhaul? Remember with CBRS spectrum, the largest channel width right now is 40 megahertz, maximum about 200 megabits downlink and 50 megabits uplink. So today you don't need anything more than a gigabit Ethernet connection. Okay, so on the FCC side as well, some of this, licensed by rule, they have spectral limits that you have to comply by. So for the infrastructure side or CBSD, it operates on a specific channel. What are the out-of-channel spectral emissions limits, and then what are the out-of-band limits? So within 10 megahertz of the operating channel, it has to reduce power output by 13 dBm per megahertz. Greater than 10 megahertz away from the operating channel, and it has to drop by 25 dBm per megahertz. So that's kind of the, you're used to the OFDM shape and spectral limits from Wi-Fi. This is very similar for OFDMA with LTE and CBRS. The further away you get from the operating channel, the lower the power output and emissions can be. End user devices, they're a little bit more flexible. So instead of within 10 megahertz of the channel and greater than 10 megahertz, it's based on the channel bandwidth. So client devices are usually cheaper quality devices. They can't conform to the same RF front-end capabilities, so they allow them a little bit more latitude to have spectral emissions away from the operating channel. So for instance, if it's a 10 megahertz channel, it'd be identical to what the infrastructure requirements are. But for larger channel widths, they give them a little bit more latitude to have the power drop off a little bit more gradually.
This is part of the certification.
This is all part of the certification process, yep. So again, a geeky detail I like to throw into my presentations, just so you have it in there to know what the spectral emissions limits are. Architectural overview, so I got into this a little bit. So this is getting into the WinForum and how the SAS operates. So again, we have CBSDs that can integrate with the SAS directly, with CBSD4 here, for example. Then you have other CBSDs. Let's say if the architecture is that we're going to do it in an aggregated, centralized fashion. You could have a domain proxy running typically on like the packet core type of solution that aggregates a number of radios and integrates with the SAS for them on their behalf. And then we have the SAS to SAS interfaces, so the SASs on the back end have to sync up. So if I'm integrating with any one of the SASs as an enterprise, I'm not integrating, let's say, with all 5 of them. If I get a grant for a specific frequency or channel at a specific location, all the other SASs and all the other enterprises that are deploying have to know about that to compute the models correctly. So all the SAS vendors on the back end sync their databases. Right now, that's being done nightly. They have enhancements that are coming to do that in more real time. That's going to be a maturation process for the SAS vendors over time. And then the SAS vendors do the ESC as well that feeds into the system for the incumbent detection. So that's kind of what the integration looks like. As an enterprise, you really just need to think about the lower portion with the radios and the domain proxy functionality.
SAS vendor get a specific geographic area in the United States or
So
kind of share amongst each other?
So the question is, are the SAS providers geographically segmented? No. The answer is all 5 of them can operate. They can control any and all portion of that 150 megahertz. It's just a matter of each enterprise and each manufacturer, which SAS vendor they partner with and which one they integrate with. And they're all required to sync up on the back end. So each SAS knows about everything nationwide that gets registered.